Hello friends, Jai Hind, Jai Bharat. Today we will learn the topic simple harmonic motion. This topic belongs to chapter of Oscillation 11 Science. First of all, I want to tell you that in 12 Science there are 3 chapters which are so important chapters. Chapter 7, alternating current, then electromagnetic waves and wave optics. In these chapters, the concept of simple harmonic motion will be introduced, so that my humble request to understand and clear your concept by watching this video. Okay. What is simple harmonic oscillation? So the simple harmonic motion, the simple harmonic motion is a kind of oscillations. In oscillations, a particle move to and fro or back and forth about its equilibrium position. Like here, it is an equilibrium position. This is the particle. Particle move like this way. So it is called oscillations. But what is the difference between oscillations and simple harmonic motion? Does every oscillations are simple harmonic motion? So the answer is no. Why? Because in simple harmonic motion there is a condition, and the condition is the displacement of the particle should be linearly proportional to the applied force. So now here the displacement in oscillation is about to equilibrium position. So the particle, it is the origin position, and here is displacement. Displacement is plus x direction. This is the displacement in minus x direction. So if we draw the graph F versus x, F is force, so if we draw the graph F versus x, then it should be equilinear, and it is called simple harmonic motion. Means however amount of the force we applied, the displacement should be same, not more. So if I apply force 5 Newton, at that time the displacement is supposed to 2 meter. Again I apply force 10 Newton. If at that time the displacement is 4 meter. If I apply force 15 Newton, at that time the displacement is 6 meter. So from 0 to 15, the displacement is linearly proportional to the applied force. So on this condition we can say it as simple harmonic motion, like this case is of pendulum. So how pendulum work? It is like this. I applied 5 Newton, means little amount, then both side there should be displacement. Again I apply little more force, there should be displacement. But finally if I apply 20 Newton force, at that time the displacement should be 8. The displacement should be 8, like this way. But instead of this, here the displacement is 12 meter. So in this case above 15, we can't call it as simple harmonic motion. It is just an oscillation. Like if in pendulum I applied force 20, at the time the displacement is increased far more. Okay, so it is not called simple harmonic motion, it is called only oscillation. So every simple harmonic motion is kind of oscillations, but every oscillation we cannot say it as simple harmonic motion. There are two kind of simple harmonic motion. If we take a block, okay, which connected to the rigid wall and spring. So if I stretch it and release it, so the ideal position is called equilibrium position. The ideal position means without stretching position. After stretching, what will happen? When I release it, it will go, okay, it will do extreme level on the opposite direction and again come, again go, again come. The surface is very smooth if you consider. Then this thing happen continuously and periodically. So it is a kind of oscillation like this. So it is equilibrium position. According to this equilibrium position, the block is oscillating to and fro or back and forth. So it is called oscillations. But here, if the applied force means after stretching, the displacement is linear, so it is called oscillation. Simple harmonic motion. Okay, like this. Now another thing is pendulum. In pendulum, okay, for very small angle, theta is equal to below 15 degree. It means for small angle theta, the bob or the sphere, the solid sphere will oscillating like this way. Okay, so it is also called simple harmonic motion. Now I want to represent simple harmonic motion in graphical way, or I want to do graphical representation of the simple harmonic motion. For this case, I will take two conditions. For this case, I will take two conditions. The first one, I will start count oscillation from positive maximum. Okay, it is equilibrium position. On the right hand side, the extreme value is, this is a plus a. Okay, it is called amplitude. It is positive maximum, and this one is negative maximum. So in first case, I will start count the oscillation from positive maximum. In the second case, I will start count the oscillation from the equilibrium position. It is our equilibrium position. If we can say it as origin or the 0 point. Okay. So this is the displacement in both sides, in positive direction, in negative direction. So it is at displacement point is equal to 0, and here we can say displacement at maximum, positive maximum, or A. Okay, so what will happen here? It is a motion. I want to represent the motion by graphical method. So I will take displacement in y direction. Okay, it is y direction. In y direction, I will take displacement, and displacement with respect to time. So I will take time in x direction. It is x direction. I will take time t in x direction. So our displacement in y direction and our time is in x direction, because if the particle is doing harmonic motion, simple harmonic motion, so with respect to time the position of the particle is changed. With respect to time, the position of the particle is changing. So for the first case, if I start simple harmonic motion, okay, from the plus a, it is called amplitude. Okay, it is called limit or amplitude plus a. So what will happen when it start oscillation from this way? So it is one oscillation. It reach extreme value on the opposite direction and again reach at the same point. It is called one oscillation or one simple harmonic motion. For this, it is takes time t. It takes time t. So it is called periodic time. So after this time, it will reach again this position. It means if t is equal to 8 seconds, so in 8 seconds it will go at the extreme value of the opposite direction, again come here. It is called 8 seconds. After 16 seconds, the same position it will reach. It will be in the same position. So I want to represent it. 1, 2, 3, 4, 5, 6, 7 and 8. Okay. And I represent the displacement in y direction. So when the particle is at plus a, okay, in the right hand side position, it oscillating, at that time it is called plus A and it is called minus A. So here at t is equal to 0, it is time t, at t is equal to 0, the position of the particle is plus A. So the position of the particle is plus A at this point. What is happening? It is one period of time, so after 8 seconds the same thing will happen, the position of the particle on the same point plus A direction. So here if to gain the same position it will take 8 seconds, so after 4 seconds the particle is at the negative direction, so it is called t by 2. It is called t by 2. Why t by 2? One period means t, so at the half period it is at the position minus A. So when the particle firstly reach the equilibrium position, it is the half of the t by 2, so it is called t by 2 divided by 2. We can represent it as t by 2 divided by 2 by 1 is equal to t by 2. It will be inverted when it come upwards, so it is 1 by 2, so it is called t by 4. So at the time period t by 4 the particle will be at the equilibrium position. Okay, so we counted one period t is equal to 8 seconds, so it is 4 seconds and again 4 seconds, 8 seconds. So if it is 4 seconds, so when it reach the equilibrium position, for this it will take 2 seconds. That means after 2 seconds the position of the particle is, after 2 seconds the position of the particle is at the origin, means here. Okay, after 2 seconds the position of the particle is here. Again after 2 seconds the position of the particle is at minus A. So after 2 seconds, again after 2 seconds the position of the particle is at minus 1. It is called t is equal to t by 2 time. Okay, t by 2 for this position. Now what will happen? Again after 2 seconds it will again come to equilibrium position. So at the 6th second the particle is at the position, here is the position, and lastly the particle reach at the same position. Same position means plus A position, so at last the particle will be at this position. So if I draw all the points, if I join all the points, then it will become like a wave. It will become like a wave. It is called cosine wave. Why it is cosine? So at t is equal to 0 our particle is at maximum. So now I want to represent this in equation form, but before that I will take the second condition. Okay, if I start the oscillation from the 0th position, Okay, same thing I have to do. It is displacement in y direction, time t in x direction. It is positive amplitude, negative amplitude. The periodic time is t is equal to 8 seconds. 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8 seconds. Now what I am doing? Okay, here in this case, look here, in this case I am starting oscillation from equilibrium position. So at t is equal to 0 time, t is equal to 0, it is 0. At t is equal to 0 time, our particle is at the equilibrium position. Equilibrium position means neither extremum nor extremum at opposite direction, nor in between position, but at the origin only. So our motion will start from this point. So the first position of the particle is at this. Okay, so what will happen here? After 2 seconds, the periodic time is 8 seconds. So when it go extreme level at the positive direction, come back extreme level at the negative direction, again come back, it is called 1 period. It is called 1 period. And for 1 period it will take 8 seconds. So 2 seconds, again 2 seconds, 2 seconds and 2 seconds. Okay, 2 plus 2 plus 2 plus 2 is equal to call 8 seconds. So in 8 seconds it will repeat its motion. It repeats its motion periodically. Okay, so what will happen? After 2 seconds it will reach the maximum plus a direction, plus a position. Okay, so after time t is equal to 2 seconds, at that time the particle will be on the plus a position. Okay, again after 2 seconds it will reach equilibrium, means 4 seconds. At 4th it will come at equilibrium position. The third time, after 2 seconds, again it will go extreme value in the opposite direction, means negative direction. Okay, so here after 2 seconds means at the 6th it will be at this position, maximum level of the negative. Again it will reach at 8 seconds, it will reach at its main position. Okay, firstly position. So here the wave will become like this. Okay, so we got two graphs. Okay, if we start from maximum, then the graph will be shown like this. Okay, now what will happen after 8 seconds? After 8 seconds, if we don't stop the bob, it will again repeat the motion. So after 8 seconds also, at 9, 10, further away, it again repeat motion. So the graph will be continuous. Same thing will happen here. In this position also same thing will happen like this. Okay. Now I want to represent this graph as a mathematical function, or in mathematical function or mathematical formula, I want to represent this motion or this graph. What should I have to do? How do I convert this graph into mathematical function? Let's see. Okay. In this figure, practically, when we oscillating the bob or the particle for small angle, at the time the displacement is linear. The displacement is linear. Okay, for small angle, like this thing happen. It is the bob, it is equilibrium position, it is extreme position for small oscillation. So the displacement is linear. Okay, like not oscillation like this, it is linear. So but the graphical representation of this oscillation, if I see the graphical representation of this oscillation, and I can found here the graph it in sinusoidal wave function. The graph is in sinusoidal wave function. So the mathematical function will become the relation between the linear and the sinusoidal wave function. So in linear, here is displacement. So for displacement, we can write it as x. X is the position of the particle, and it is a motion, not it is static. It is motion, so the position of the particle should be changed with respect to time. The position of the particle should be changed with respect to time. So it becomes like xt. Okay, so the left hand side of the mathematical function should be like xt. What is it represent? It represent the position x. X is the position of the particle with respect to time. It means, according to this figure, at time, if we take the time t is equal to 0, at the time the position is at this point. Okay, at time t is equal to 2 seconds, the position of the particle at this. Okay, let us relate this with the practical. Okay, practically experiment. So at t is equal to 0, I start from here. So at t is equal to 0 time, the position of the particle is at this. Okay, I start count during oscillation. When it at this position, I start count at, okay, I start count here. So what will happen? After some time, it will go extreme value in the opposite direction and come back. Okay, so it will become one oscillation. So for one oscillation, it is take 8 seconds. Here in this example, it is take 8 seconds. So at 2 seconds, okay, at 2 seconds, the position of the particle is equilibrium. So at 2 seconds, here in displacement, equilibrium means no displacement. X position is at 0, it is 0 point. So at 2 seconds, it is at 0 point. After 2 seconds, it will be at extreme value but in opposite direction. After 2 seconds, it is in opposite extreme value but in opposite direction, like this. So this is the graphical, it is the experimental representation or linear. And now on the right hand side, I want to write down this graphical representation in mathematical form. So here, if we look, it is like a wave. It is like a wave, and after a certain period of time, it repeats again and again. It will go further, okay, like this way. So here it is a time period t. After time period t, again it will be repeat. Again it will be repeat. Okay. Now look this figure here. In one period of time, it is the 1/4 of the circle, like this. It is 1/4 of the circle. It is also 1/4 of the circle. Okay, so it is like this. Again, this is also 1/4 of the circle. So this portion is like this, and the fourth one is, it is also 1/4 of the circle. So it is a full circle. It is a full circle. So in one period of time, at which position from we start, after one period of time, it will cover a full circle. If I start from here, okay, so at 9 seconds it will reach here. Okay, so if I draw from this point to this point, it is a period of time. So again it will make a full circle. So from which point I will start doesn't matter. After a period of time, it will cover a full circle. It will cover a full circle. Okay, the displacement is linear. The displacement is linear, but the graphical representation is sinusoidal. The graphical representation is sinusoidal. And if I combine the graphical representation of the one period of time, then it will become a circle. It will become a circle. So here, this is a kind of circular motion. It is a kind of circular motion. I mean, the graphical representation is a kind of circular. Okay, so in a circle, if I start from 0, and cover the whole path, then it will become, it is 90 degree, again it is 90 degree, third time 90 degree, fourth time 90 degree. So 90 multiplied by 4, it is 360 degree. Here it will become 360 degree. So what will happen here? Okay, here from 0 to this position, it will become 90. It will become 180 degree, 270 degree and 360 degree. 360 degree means 0. It will reach at its firstly position. Okay, in radian, for 90 degree we can call it as pi by 2. For 180 degree we can call it at pi. For 270 degree we can call it as, if it is pi by 2, the whole is pi, then it will become pi by 2, pi plus this distance is also called pi by 2. It is called 3 pi by 2. At 270 degree is called 3 pi by 2. And the whole circle, okay, it will become pi. So 360 degree will become 2 pi. 360 degree will become 2 pi. It is in radian, it is in degree. It is in radian, it is in degree. Okay. Okay. Now focus on experimental phenomena or practical. Here it is a pendulum and this is the oscillation. So what is happening here? And it is the displacement about according to equilibrium position, the displacement. Now in experimental phenomena, I want to find the frequency. So how can I found that number of oscillation per unit time? It means I started here, so it is one oscillation. For one oscillation it will take a periodic time 1 period, it means t. Okay, so in t period time number of oscillation is 1, or in t period time one oscillation happen. So in unit time, okay, 1 unit time, how much oscillation it will happen? So there is the answer, and the answer is 1 into 1 divided by t is equal to 1 upon t. So the frequency f is equal to called 1 upon t. Frequency f is equal to 1 upon t. It is linear. In linear we found f is equal to 1 upon t. What about this graphical? In graphical it is like a wave, and in one period of time it cover a full circle. It cover a full circle like this. Okay, 1 by 4, 1 by 1/4, 1/4, 1/4. So in one period of time, during from this point to this point again, it will cover a full circle. In graph it will cover a full circle like here. So in graphical method we can say it is one oscillation. So it is one oscillation, and for one oscillation it will take t time. Okay, so time is same, t. Okay, one periodic time is same, t, but the full circle here, the full circle means 0 to pi by 2, okay, pi, 3 pi by 2 and 2 pi. So in one period of time it will cover the distance 2 pi. So we, instead of 1 here, instead of 1 we have to take 2 pi, and the time period is, for oscillation the time period is same. Okay, 8 seconds. In pendulum 8 seconds, so it graphical represent also denote here 8 seconds. So time period is t, so 2 pi by t, and we can call linear frequency as f. So we can call here as omega. Okay, so we can call it as omega. But here we can see 2 pi is distance in circular, okay, and t is time. So distance upon time is called velocity. Distance upon time is called velocity. It is angular. Look, it is pi by 2, okay, pi or 180 degree, 90 degree. So it is angular. So this is linear frequency, and here omega is called angular frequency. Okay, but distance upon time is velocity, so we can also call it as angular velocity. Omega is called angular velocity. But we want only position of the particle, or we want only displacement. Here displacement according to equilibrium position, but here we have velocity. So what should we do? If I multiply velocity with time, or I take the time from denominator on the opposite side of the equation, okay, so it will on the upside, okay, so velocity into time is called the distance, okay, velocity into time is called the distance. So if I multiply omega with t. So it will become distance. So here also is distance, on the right hand side also is distance. So it will become the same. Okay, xt is equal to omega t. Now during the oscillation, I started count the oscillations from the extreme value on the right hand side. It means plus a position. Okay, I started count from plus a position. It means when I start the stopwatch, at the time, at the instant of starting or the before starting, it is the bob or the sphere, it has this position, or here at this position. So after one period of time, again it will reach at this position. So it means at t is equal to 0 time, the position of the particle or the bob is at a, okay. So we can say here that at t is equal to 0, x t is equal to 0, the position x is at a. Okay, so here I have to take t is equal to 0. I have to take t is equal to 0. Now it is in one period of time, it is a circle. Okay, one period of time it make a circle. Okay, if I combine both all the part, it will make a circle. In circle, how the value is changing? So we can see here from 0 to 90, 90 to 180, 180 to 270, 270 to 0 again. I will take here only for 0 to 90 degree the value of sine and cosine. Okay, from 0 to 90 degree, not the whole circle, but it is okay. By this 1/4 portion we can introduce all the part. Okay, so I will take from 0 to 90 degree only. So for 0, sine 0 is equal to 0, sine 30 is equal to 1/2, sine 45 is equal to 1 upon 2, sine 60 is equal to root 3 upon 2, sine 90 is equal to 1. So if I take sine function, so sine at 0 degree, 0 degree means here, so here it will become 0, and sine 90, for sine 90 it will become 1. It will become 1 means extreme, maximum position, 0 to maximum. Okay, for cos it is just reverse, it is just inverted. So when I take cos 0 degree, so it will become maximum. Cos 0 it will become maximum. Cos 30 root 3 by 2, cos 40 1 upon root 2, cos 60 1 upon 2, and cos 90 is equal to 1. So for cos value, cos 0 is equal to 1 and cos 0 is equal to 1 and cos 90 is equal to 0. Sorry, it is my mistake. Okay, so in this graph, in particular this graph, okay, we are starting from maximum value. Or in the experiment we start count the oscillation from extreme value. So look here, look in the graph. At t is equal to 0 time, the graph is not start from the 0 like in circle. It is 0 and here it will make pi by 2. So it not start from the 0 but it start from the value pi by 2. So here I will take the value as pi by 2. In degree it is called 90. Okay, in radian it is called pi by 2, here 0 to pi by 2, but in degree it is called 90. So for this graph, okay, if I put 90 degree, so we have to take value of omega is equal to 90 degree. Okay, so if I take sine 90, sorry, my little mistake, here omega t is shows the position. Now at t is equal to 0, if I put the value t is equal to 0, so it will become omega into 0. So this term will become 0, this term will become 0, and the graph start from the maximum value. Okay, it will become like a pi by 2, and the graphical representation is sinusoidal wave. The graphical representation is sinusoidal wave. So here I have to write either sine or cosine about the omega t. So if I take here, its value becomes already 0. Its value become already 0. So if I take here sine 0, so I found the value 0. Okay, and what is 0? 0 means the position of the particle, and here okay, again for t is equal to 0 time, omega into 0 will become 0. So and the whole wave is the graphical representation is sinusoidal wave. Okay, so for sinusoidal wave I have to represent it either by sine or by cos function. So this term already becomes 0. So if I put here sine 0, so it will become 0. Okay, so what does it mean? It means that the particle is not at maximum value, or the particle is at the 0th position. But here if I put the value sine 0, like here sine 0, then our graphical representation should be wrong. But instead of sine, if I put here cos, okay, instead of sine, if I put here already value comes 0. So if I put cos, so that means cos 0 means 1. So cos omega into t is equal to 0, it will be found it cos 0 is equal to 1. 1 means here maximum value, and already it is maximum. That's why when we start our motion, when we start count the oscillation motion from the extreme value, at that time we consider only cos function. It start from here and it is denoted by xt here. Xt is equal to cos omega t. Xt is equal to cos omega t. Now if I start count oscillation from equilibrium position. So from here it will go maximum to the right hand side, again come back, again maximum to the left hand side, again come back. So I started from this position. For this graphical representation, we already seen that at t is equal to 0, the position of the particle is at equilibrium position. It is so the graphical representation will become like this. And in this graphical representation, if I write is a mathematical function, so it will become like this, omega t, so omega into 0, so this term will become 0. So here in this case, if I put sine, so what will become sine 0. So sine 0 is equal to 0. So for this condition, we are taking xt is equal to sine omega t. So that is why we are taking, when we start the oscillation from origin, at that time the graphical representation should become like this, and the graphical representation become like this. At that time we denote it in mathematical formula xt is equal to sine omega t. But when we start the count of oscillation from the maximum value, either this or this, okay, here we are taking on the plus a, so plus a is upside, so we are starting oscillation from this. At that time the wave function will become xt is equal to cos omega t. So we have two conditions, okay. If we start from the extreme value, then it will become xt is equal to cos omega t. If we start from equilibrium position, at that time xt is equal to sine omega t, okay. So now there is only two probability that we can start only from extreme value or from mean position. No, can't we start from in between some position? Yes, of course, we can start it like this. It is our pendulum, okay. It is equilibrium position, it is plus a this distance, it is minus a this distance from equilibrium, okay. So it is one period of time t, okay. I start from here in first case, in second case I started from the mean position. Now if we cover one period of time, it is t, it is t by 2. So from this point to this point it is t by 4, okay. So it is our t by 4 distance. The whole distance means from this point it goes this opposite direction, maximum value, again come reach at the firstly position. So it is called one period of time. So it is half, so it is called t by 2. If it is half t by 2, then it is half of half, means t by 4. It is t by 2 this distance, and this distance is t by 4. Now what I want to do, I want to start count the oscillations from this point, okay, when the bob or the sphere is in between these two positions, the extreme value, extreme positive value, and the equilibrium position. In between this position, if I want to start the oscillations, then how the graphical representation should become? Okay, let us see. Here, for one period of time, I will take 8 seconds. Okay, so in graphical representation, 1, 2, 3, 4, 5, 6, 7 and 8 seconds. 3, 4, 5, 6, 7 and 8 seconds. Okay, from equilibrium position, it is equilibrium position, it is maximum A, it is also maximum but in opposite direction. So same here, it is equilibrium position, so it is plus A, it is minus A. So now what will happen? Now I take the mid position from the equilibrium and the extreme value. So it is equilibrium, it will extreme value, and I take this point. Okay, okay, now look here. Here the bob is oscillating. The bob is oscillating. It is simple harmonic motion. Okay, it is no, this angle is very small, theta is very small, so it is like displacement. Okay, it is like this. The bob is oscillating like this, so it's oscillating continuously. So in another hand I have a stopwatch, in another hand I have a stopwatch like this. So when it oscillating, at that time when it reach at this position, when it reach at this position on this direction, okay, on this direction, when it reach at this position, at the time suddenly I start the stopwatch. So I start the stopwatch, so at the instant of time, it is called t is equal to 0, the position of the bob is in between mid position and the right hand side extreme value, extreme position. So it is mid position and the extreme value of the positive side. So at t is equal to 0, it is time t, okay, it is x, it is y. At time t is equal to 0, our particle, okay, at time t is equal to 0, it is 0, our particle is at between mid position and the extreme position. It is mid position and it is extreme, so it is between this position. Now the direction is on the right hand side. Right hand side means positive, it is 0, so from the 0, the positive side, the right hand side is positive distance, it is negative distance, so afterwards it will go and reach extreme value, it will go and reach extreme value. I took the time period of 8 seconds. So what will happen if I start count from this position? So it is 2 seconds, again 2 seconds, on the opposite side 2 seconds, again 2 seconds, 8 seconds, it is time period. So for mid position to the extreme value, if it take 2 seconds, so from half of the position it will take 1 second. Okay, so from bob's position 0 to this, it is 1 second, again it is 1 second. Okay, so at t is equal to 0, it is at this position. So after 1 second, t is equal to 0 at this position, after 1 second our bob will be extreme value. Extreme value means plus a here. Okay, so our bob is extreme value plus a here. Okay, then after what will happen? It will go to the extreme value of the left hand side or opposite to the mid position. So if I start count from here, okay, wait, here what will happen? It is 2 seconds of time and it is 2 seconds of time, so it is 4 seconds of, but I start count from the 1. So after 2 seconds at 3, okay, after 2 seconds it is 1 second, 2 minus 1, it is 1 second period of time, it is 1 second, so it will reach at the mid position. Again after 2 seconds, means we have to add 2 seconds, it will add the extreme value of the opposite direction. So after 2 seconds it will add the 5, we need 9 also, okay. So again after 2 seconds it will reach again the equilibrium position. So 5 means after 2 seconds, 5 to 6 and 6 to 7, again it will add the equilibrium position. And lastly after 2 seconds what will happen? It will reach at this position. So after 2 seconds it will reach at this position. So our graph will become like this way. Okay, so look here, if we draw the line here and if we start count from here, so what we look, okay, here it is from 90 degree, so it is cos function, and it is one period of time, here it is one period of time, okay. So for one period of time we can say it cos omega t, it is called cos omega t, but we have additional portion here, so we can call it as phi, okay. It is constant value. Why it is? It is because that we start our oscillation countation from somewhere which is not the location at the extreme value or the mid position. So our graph will become like this. And if we start one period of time from this position, so it is in between mid value and extreme value. So after one period of time means 8 seconds. After 8 seconds, if I look here, it is one period of time. So after one period of time, it will reach its firstly position like this. I started count here. The direction is this. So it is 1 second, 2 seconds. Okay. It is also 1 second, 3 seconds, 4 seconds here, 5, 6, 7 and 8 seconds. So after one period of time, it will reach its firstly position. So if we see this graph, there is a difference, and this difference is of 1 second. So it is additional difference is called as phi. So it is called cos omega t plus phi. Here our function xt will become cos omega t plus phi. Suppose, I don't know, I explain by myself so you can understand. So if in general our equation will become, our equation of the simple harmonic motion will become xt is equal to a cos omega t plus phi. Okay, a means extreme value, amplitude. Okay, the value of a is change. How it will become change? It will become change due to this term, according to this graph. It will become change with respect to cos omega t, a cos omega t, when the value will become extreme value. Okay, so at this time at extreme value here at t is equal to 0, this term will become 0. There is no additional phase like this, there is no additional portion because we started from here. So here phi value become 0, so phi value become 0. So for this condition our value is become a cos 0. And what is the value of cos 0? We have seen here, cos 0 is equal to 1. 1 means extreme value. So here is 1 into a. So our term will become xt is equal to a, means plus a. I will write again so that you can understand well. X t is equal to a cos omega t plus phi for this graph. Okay, so here it will become a cos, at t is equal to 0 time it will become omega into 0 plus phi, also as shown in this figure. Okay, there is no additional term, we started from here 0 to 0, so the value of phi should become 0. Okay, a cos 0 plus 0 is equal to a cos 0, the value of cos 0. Okay, from here cos 0 is equal to 1, so a into 1, so it will become a, positive a. At t is equal to 0, the value is become a. Now okay, in this graph as we shown above, that for this kind of graphical representation we are taking sin omega t plus phi. So our equation will become sin omega t plus phi. At t is equal to 0, what will happen? Okay, x t is equal to 0 is sin omega into 0 plus phi's value also is 0, so instead of phi we will take 0 is equal to sin omega into 0 plus 0 is equal to sin 0. Okay, sorry, I made a mistake, here we have to write a. Okay, why we are writing a here? Because look here we start oscillations. Okay, from here it will go this way, maximum plus maximum minus maximum. I started from here according to this graph, so first it become plus maximum, minus maximum, again plus maximum, again minus maximum, so its value change according to a. Okay, so here a is there, but at t is equal to 0 this term will become 0, a is presented here but sin 0. So what is the value of sin 0? Here look, sin 0 is equal to 0, so we can write a into 0, so the whole term will be 0. So we can say that at t is equal to 0 the term will become like this. So at t is equal to 0 there is no displacement, it is on its origin position, 0th position, so we are right here. But in the third case there is a phase difference, so in this case if we look, it is cos function plus some additional term, so this additional term denoted by phi, so a already present here, so xt is equal to a cos omega t plus a cos phi. So here this equation the value xt is the full a cos omega t, okay, plus this is the term a cos phi, means additional this term will present. So if we start count the oscillation from equilibrium position or from extreme position, on both side, okay, at that time the value of this constant, okay, it is called phase constant, the value of phase constant will become 0. But except these three conditions, if we start count oscillation in between the equilibrium position and extreme position on both the side, at that time our phase constant has some value. So in these two cases, in this case a cos omega t plus phi, at that time the value of phi will become 0, and in sin omega t xt is equal to a sin omega t plus phi. Same here, at the time also the value of phi will become 0. So finally we can say that in simple harmonic motion, the displacement of the particle with respect to time we can represent it in graph, and the graphical representation we can explain or we can compare the experimental phenomena or linear displacement and the graphical representation with this mathematical equation. And if we start our oscillations from the equilibrium position, then our graph should become xt is equal to a sin omega t plus phi. So our graph will become sine. So from 0th position if we start, it is called sine wave function, and if our oscillation we count from the extreme value, the number of oscillation we count from the extreme value, then the graphical representation should become like this way, and it is called cos. So for this graph our equation will become xt is equal to a cos omega t plus 5, and accept these two conditions. If we start count from in between any position between the equilibrium position and the extreme position, at that time our graph will become like this, okay. So in this graphical representation it is a full sine or cos function plus some additional function. So we can count it as a cos omega t plus phi. So here the phi term will has some value. Except this, in this both case phi terms will become 0. Okay. So thank you all. Jai Hind, Jai Bharat.